Welcome everyone to another Egypt Ocean webinar. While I wait that everybody gets in through the door, I'll share a couple of introductory slides. So good to see so many participants here today. So my name is Lotta Pirtima. I'm from Ocean Energy Europe, who coordinates Egypt Ocean, the European Technology and Innovation Platform for Ocean Energy, together with Technalia. And today we will talk about ocean energy testing facilities. So of course, as we're in an innovative sector, developing new technology, testing in tanks, labs, doing dry testing, or then of course real sea testing, all are very important components in reducing the cost and validating the technology, and then getting the technology closer to market. So that's why we have today a good selection of speakers, all kind of taking a different angle on the topic. But we will, as always, start with the introduction to kind of looking at the background of where this topic is coming from. And then we have these three presentations from Fiona, Giacomo, and Eileen. And at the end, we'll have time for a Q&A. So if you have any questions throughout the presentations, you can put them in the Q&A box and we will take them at the end. And the whole webinar will be recorded and available on the Egypt Ocean website, as well as all the presentations from today, so you can take a look at them afterwards as well. With that said, I think we can start with the introduction. So Pablo Ruiz-Minguela from Technalia, the floor is yours.
Thank you, Lotta, for your introduction. I will spend the next 5 minutes introducing the SREA and the subject under discussion today. But I will start by sharing my screen. Hope you can see it now. Yeah, can you see it in presentation mode?
Yes, perfect.
Okay, perfect. So as I said, I was going to introduce briefly the strategic research and innovation agenda. I'm sure that by now most of you are aware of this document that was officially launched in its new version in October last year, and covers the period 2025 and 2030, so the next 6 years. This is a reference document for the sector, which identifies the key research and innovation priorities that have the greatest impact on the sector's progress, and defines the specific objectives and actions with the aim of accelerating the development of ocean energy and therefore paving the way to commercialization. In this way, it provides guidance to all funders of innovation, encompassing the industry and all the funders, organizations at the European, national, and regional levels. You have a link to download in the slides that will be shared after the webinar, but also can be downloaded through the Egypt Ocean website in the document library. The SREA, for short, the Strategic Research and Innovation Agenda, is structured in several challenges, which are the research and innovation priorities. These are fields that the ocean energy sector has identified as most worthy of investment during the period covering 25 to 2030. And the first one of these challenges is the design and validation of, which is believed to be and agreed by all the sector stakeholders to be the central priority to achieve an ambitious cost reduction. This first challenge, design and validation, is supported by 4 challenges, which the aim to increase technology maturity and prepare for large-scale deployment. Those cover the next generation of technologies and subsystems, analysis and modeling tools, the integration of enabling technologies, and the ocean energy market development. Last but not least, all of these technical challenges and research and innovation priorities are supported by coordination actions which support the innovation efforts to leverage the private investment needed to make ocean energy commercial. The challenge areas are broken down in priority topics. There are 18 of them. I won, well, here you got in the slide the 18 priority topics, but I won't enter into further descriptions. The document it has a structure with a general overview of the challenge concern, one of the 6 challenges, and a specific description for each of the 18 priorities, which involves briefly outlining the context, the main impacts expected, which are making ocean energy competitive, reinforcing the industrial capacity, filling in the knowledge gaps, increasing the environmental and social acceptance, and attracting more private investment. The applicability that can be either wave energy, tidal stream energy, of other ocean forms of harnessing ocean energy, the scope of actions, the expected outcomes, and some implementation aspects. Among them, there are the expected TRL or ranges of TRL for projects to be funded, the type of actions to be funded, demonstrations, basic or applied R&D or any other kind of support projects, an indicative number of the number of projects, and the size of projects, also an indicative figure. This will help the funders identify the instruments in order to address the challenge areas and priority research and innovation priorities. Today, we are focusing on the accessing and upgrading testing facilities, which is one of the 18 priorities in the current SREA. And this topic is expected to impact on reinforcing the industry, filling in the knowledge gaps, and increasing the social and environmental acceptance. It is applicable to any kind of ocean energy device. In terms of implementation, the TRL sought is relatively high, with a estimated number of projects 8, and size of projects ranging from small to medium and large, and the type of actions should be mainly demonstration. The scope of actions focus on the maintenance, upgrading, expansion, or accreditation of these testing facilities, which might be onshore labs, test rigs, and at-sea testing facilities. And examples of actions are suggested in the SREA, such as accessing or giving access to test facilities, the use of hardware in the loop for early stage model calibration, the developing and certification of software simulation environments, the design of more efficient test campaigns, the collaboration, enhancing the collaboration between testing facilities, and the standardization of testing and assessment procedures. Finally, the expected outcomes in order to address this challenge and priority topic is to increase the participation of local industries in the ocean energy supply chain, the improved knowledge gain in the critical failure modes and survivability of ocean energy devices, the increased reusability of data sets, respecting obviously the protection of the company IP, and the contribution to establishing common protocols and guidelines for the design, testing, and operation of ocean energy devices. I think this is all from my side. Thank you, and pass on the floor to Lotta and the rest of the speakers.
Thanks a lot, Pablo. And I put a link for the SRA in the chat, so you can get your digital copy from there. Now let's start with the presentation. So first we have Fiona Devine-Macaulay from University College Cork talking about collaboration between testing facilities. So
Hi, can you hear me okay?
Yes, and we can see your slides.
Okay, I'll start
Great.
though. So my name is Fiona Devine-Macaulay and I'm from University College Cork in Ireland, and I was going to speak to you today on an initiative we're coordinating that will impact the future landscape of ocean energy test facilities. So many of you may be familiar with funded access programs, EU funded access programs we've coordinated in the past, including Marinet and Marinet 2, and we're currently involved in the ocean energy aspect of Rise Energy, which is providing access programs for developers to use our test facilities across Europe. And what we found from those projects was the advantage of collaborating on access programs and improving the efficiency of those access programs, as well as collaborative research. And what we found was the need to move from these transitional projects to a permanent legal entity, a distributed research infrastructure of testing facilities that we want to accelerate the delivery of offshore renewable energy, ORE, so ocean energy, offshore wind, etc. And so we're currently in the process of setting up Merenergy as this permanent legal entity to provide a step change from transitional projects providing access programs to a permanent legal entity that will exist beyond those projects through the support of EU funding on the S3 roadmap. So our mission really is to drive the development of innovative and investable ORE technologies, streamlining research, testing, training, and user access to a range of facilities across the EU. Those facilities would adopt common codes of practice for uniformity in testing, performance metrics, validation, and certification, and also implementing a federated e-infrastructure platform to facilitate knowledge exchange and access to services. So hopefully going beyond what we're able to do in a transitional project. We also want to accelerate novel solutions through cross-sector collaborations and integration of distributed testing infrastructures, and ultimately inform national and EU policy and infrastructure investment strategies, sustaining global leadership and recognition in the sector for the EU. So what do we look like currently? Well, the DRI, or the Distributed Research Infrastructure, will be made up of country members. So at the moment, Ireland is the host. So we're going to host the Merenergy Central Hub. We also have received government support from the UK, Belgium, Portugal, Spain, and the Netherlands, and are in the process of getting that government support from France, Italy, Norway, Germany, and hopefully Sweden. And we've identified around 60 facilities across Europe, as you can see, distributed by the orange dots, that we would like to participate and provide access to their facilities through different access programs. And what will we cover? So floating wind, wave, tidal, floating solar, mooring systems and anchors and components, the electrical, power quality, performance and grid integration, drivetrains, generators, electrical components, device components, logistics and robotics, structures, materials, geotech and manufacturing. So that's the current makeup of the offering. And in terms of what sorts of facilities and the scales they're at, we're talking small labs, large labs, open scale, medium-scale open sea test sites and large-scale open sea test sites as well. How have we come up with these 60 facilities? Well, based on our experience from the funded access programs in Marinet, we can see where the demand is in terms of the size. So there's a great demand for sort of our large scale labs. And in terms of the category, there's a great demand in terms of wave energy developers. So that's where we have taken the initial makeup of our facilities. Just to give you a taster of who's involved, we have, and you can see these in the slides after the webinar in detail, but we have our own Lear National Ocean Test Facility that's in Cork. We have, trying to think of the ones that are on the call, but Fastblade, the Sweet Lab Structural Component Test Rig and Drivetrain Test Rig. Large-scale labs in Belgium, we have the Cobb Wave Basin and Towing Tank. In large-scale labs still, we have Sener, IH Cantabria, Sindef Ocean, Marin, Flowwave. Medium-scale test sites, we have Sino and St. Anne test site. And large-scale test sites, we have Smart Bay, Plocan, BMEP. So that's just a few of the ones that we have involved in EMEC, of course, who are on the call as well. And what sort of services will we particularly offer? Well, the first and foremost, we want to streamline the access to our test facilities. We also think that we could offer assistance to developers in facility selection. What's the best facility for them? What's the one that's available? And also technology development guidance, training both internally for those working in our facilities and also external training for users. Data processing, curation and access, and knowledge-based dissemination from what we're learning from our research programs. How will we supply these services? This would be through our e-infrastructure, which would initially look like a website and would contain elements such as science and innovation that would give you information on our research projects, outreach activities. We'd also have a member and participant portal for internal use, but we'd also have a community portal where we would hope to foster a networking community in the ocean energy sector, a services portal where you can apply for access programs that we have available, training and other services, and a data portal where we'd hopefully have data sets available per facility, data tools, and a virtual research environment. So what is the added value we hope to achieve? Well, first and foremost for developers, streamlined access to our facilities, more funded access programs for you to avail of. We also want to improve the quality and standards across our facilities, and by having common standards to improve the quality of testing outcomes. We also think that that will help reduce risks, improve investor confidence, and make the pathway to certification easier. So through collaboration and networking, we also want to leverage the individual capacities of our research facilities. And we also want to improve the planning and efficiency of how we operate through this collaboration and the future planning of test infrastructure development and ultimately inform policy. So at the moment, we are becoming a legal entity. We hope to be established 2026, 2027 probably. And then we hope to be able to supply a pilot access program by 2028. But for us to be able to do that, we need to show further evidence that that access program is needed by developers and users, that there is a demand there for it. So what we have at the moment is a potential user survey. If people would take a few minutes just to fill that in, it just would give us an information on what facilities you may have used in the past, what you would expect to use in the next 5 to 10 years, and particularly how you have funded the use of those facilities. Has it been through private funding, public funding, a mixture? So far, what we've had back in the survey is that 71% of respondents were SMEs. Test facilities needed over the next 5 to 10 years, particularly were the wave and current basin or flume, and 25% are going to need open sea test sites, with 15% requiring full-scale testing. And 65% said funding is the main decision driver to using these facilities, with everybody suggesting that they either need public or mixture of public and private funding, except for 6% who said other. So again, it would really help our case when we are talking to potential funders for access programs if you could fill in this survey to add to us developing a compelling argument. So that's all I had, Lotte.
Thanks, Fiona. You can leave the slide while I ask you a question that I saw just here.
Sure.
What is the participation from the Dutch government or the Netherlands in this marine energy?
Yeah, so we actually have, between us getting on the S3 roadmap, and since then we've had government support from the Netherlands. So they've signed a letter or an expression of support. And in terms of the participants, we have our national contact is DMEC, and they basically would coordinate all of the potential facilities that would be involved. And just to go back to some of the ones we have Marin, obviously. We would also have a number of TNO facilities, the DNW, and there's the TNO wind turbine test sites in particular. Does that answer your question, Lotte?
Yeah, perfect. Thank you. And maybe just very quickly, if you have the number, what's the absolute number of responses so far that you've collected?
I think that so far we're at 32, so more would be very much appreciated to help us.
Great. I hope everybody has got the QR code now opened up. But if not, of course, you can find it on the slides afterwards. Thank you very much, Fiona. Let's move on to try testing. So now Giacomo Alessandri from VGA will talk about their experiences and in the try testing side of testing. So we can see your slides, so go ahead. Thank you. You are muted.
Okay, can you hear me?
Perfect. Yeah, perfect.
Thank you very much, Lotta, and good afternoon, everybody. So yes, I'm gonna present offshore lab testing linked to ocean energy. I'm Giacomo Alessandri from VGA. And yeah, the agenda from today will see firstly an introduction about VGA, then we'll have a brief look at the challenges in ocean energy development. Then we will deep dive into VGA's Suite Lab, and we'll also see 3 examples of testing and assessment methodologies. And finally, we'll have a review of the possible upgrades and expansion plans for our facility. Before a quick look about VGA, VGA was born as an engineering service company and developed through the years, also thanks to R&D projects. And today, our key products are test rigs, followed by energy storage systems and actuation systems for niche applications. As you see from the slide, testing and R&D in ocean energy are among our portfolio. So this is exactly the topic I will go throughout my presentation. But before we will have a quick overview of the challenges within ocean energy. I have listed some of the key challenges here, and to let all the audience understand how these are linked, can be linked to onshore lab testing. So first of all, there are variable input conditions, so we need to validate the performances over a wide spectrum for these devices. Especially for wave, we have a very high peak to mean load ratio, meaning that we would be forced to oversize our device or any way to optimize the control to reduce as much as possible the possible oversizing. The environment is quite challenging, so we have corrosion and biofouling that needs to be addressed. At the same time, we have high deployment and maintenance costs. So there are few chances to iterate and upgrade the design using the learnings from the deployments. Also, for some specific cases, there is a lack of componentry for ocean energy applications. So R&D is required for those cases. And last but not least, there are more advanced renewables that have already reached the market. So we have a few time to address all these challenges. What I would like to convey today is that a comprehensive onshore lab testing campaign could be a key for reducing the risks, especially prior at sea deployments. And this can be carried out with reasonable time and costs, especially if compared to sea trials. With this approach, within the Impact Horizon 2020 project, we developed a novel testing facility that is called Sweet Lab. We approach this problem looking at the technology evaluation areas and prioritizing these 4 evaluation areas, but also you can use this facility to derive and extrapolate useful information that can also inform maintainability and affordability. So over the next slides, I will guide you through the rigs that are belonging to the Sweet Lab. We will start with the drivetrain test rig, which is a rig aiming at testing also individually all the components between the wave-induced input mechanical power and the electrical power at the grid interface. There are 2 actuation systems on this rig. One caters for linear power takeoffs on the right side, on the left side for rotary power takeoffs. In addition, we have also integrated a grid emulator to offer the testing of the grid interface units. Complementary to this rig, we have the structural components test rig. Indeed, we can use this rig for increasing the number of components and subsystems that can be tested and de-risked at lab. So this rig allows to carry out mechanical tests with different actuation systems available, but also environmental stresses could be introduced, for example, by submerging the sample with synthetic seawater. But more than that is the conception of this rig was also guided by the ocean energy community, because we gathered input from the technology advisory board members and through surveys that were disseminated through the ocean energy community. Rigs do not work by themselves, but it's very important also to have testing and assessment methodologies that follow a very structured process. So first of all, it's very important to carry out this process in strict collaboration between test facility and ocean energy developers. The first step will be to understand what are the customer needs and the development status, so that we can identify the subsystems that are that urge mostly testing, and also according to the development status of the company, we can address if are more needed baseline tests, or for example at higher TRL we will need more advanced tests where we can target quantitatively 1 or more technical evaluation areas. Another key aspect of test is the critical review of the results. We need to understand if target KPIs are reached or not at the end of test, and if not, understand why. And another very important aspect is that as much as possible, standards, applicable standards should be followed throughout the testing process. So in the next slides, I will present 3 different approaches that can be used in onshore lab testing and also at Sweet Lab. The first is hardware in the loop, which is the state of the art, not just in ocean energy. And basically this approach includes the hardware, the real hardware, that in this case is the power takeoff, integrated into a test rig and connected to an actuation system whose command is driven by a numerical model. We have into the numerical model the device simulated, and this device streams real-time actuation data at the actuation system of the rig. At the same time, the power takeoff will react according to its control strategy, and we can measure this reaction and feed this measurement back to the simulated environment to close the control loop. So this way we can integrate a real hardware into the numerical model. But we can also do the same, not just from the mechanical perspective, but also using a grid emulator and actuating the grid interface of the drivetrain. So this approach allows to assess the performance and the functionality of the subsystem, of course, using representative loads given by the numerical model, and this we can be used to increase the fidelity of the model, and finally to see what is the response of the overall device according to real inputs. The same approach can be not only applied to drivetrains, but also to other type of components using the structural components rig. This can be used to test, for example, mooring line, power cables, and structural components. Within the impact project, we also went beyond the state of the art, conceiving, testing, and demonstrating the dual hardware in the loop approach, which foresees the simultaneous testing of two different components or subsystem, each one installed on a different rig with the simulated environment, sending real-time actuation inputs to both rigs and gathering feedback data. And this practice has proven to be very useful to identify interdependencies between the two real subsystems, to verify what is the response of the WEC model using the real inputs from these subsystems, and also to further increase the numerical model. Another relevant approach that is required to increase the efficiency of tests and also to address the aspect of failure modes is accelerated live testing, which is a methodology to address reliability feature of a subsystem in a reduced amount of time. This can be used at early TRL, mainly to identify design issues or also to see what are the key failure modes of a component or a subsystem, but at the same time at ITRL can be used to define key parameters of the reliability and also to identify manufacturing defects. However, accelerated methodologies are not easy to set up. They require, first of all, a very deep knowledge of the device under test and also an understanding of how the different stresses can affect the degradation of the system. These are required to set up a comprehensive test plan. At the same time, even if accelerated, they require a considerable amount of time, so even the associated costs are higher with respect to other type of tests. But at the same time, accelerated lab testing can give very relevant benefits. First of all, the results can be specific to your device and your product and calibrate operation and maintenance model. I would also like to present some future update plans for the drivetrain rig to increase the power of grid simulator for using the PTO as an actuation system, for example, in cases of maintenance or installation, simulating the device life cycle. In terms of the structural components, to add interfaces that allows us to test different type of components more straightforwardly, and at the same time, in parallel, to get the certification for testing and calibration accredited laboratory. I would also like to link back to what Fiona said about the Rise Energy project, because our facility is also one of the facilities that is accessible through this funded program, which currently is the only program that funds access in Europe to test facilities. Thank you very much.
Thank you, Giacomo. So just a quick question before we move on. So can any type of WEC use these test rigs?
Yeah, we conceived and developed both rigs to be compatible to most of the WECs, and but more than WECs, we focused on subsystems, because here we are testing components and subsystems. And I remember we also calculated a percentage which was of above 90% of the subsystems associated to both rigs with respect to any different existing type of wave energy converter. And also, I have to say that this is also applicable in other cases to tidal energy converters. So it's not just wave.
Great, thank you so much, Giacomo. Let's move on to our third speaker, Eileen Linklater from EMEC, which is the only certified ocean energy test site in the world. Eileen, you'll talk more about that and yeah, what you're doing at EMEC.
Good afternoon. Thank you, Lotta. Yeah, my name is Eileen Linklater and I'm the Corporate Affairs Director here at EMEC. So part of my role is to oversee the quality standards. And the task today is to talk to you a little bit about standardisation of testing and assessment procedures. And I hope this will build on the introduction from Fiona and the onshore facilities, which Giacomo's talked about, because I'm now going to take you offshore. And what I hope is that I can share with you some experience from more than 15 years of working here at EMEC. So in that time, I've seen the evolution of the standards work and the development of the international technical specifications that we work to. So as a bit of an intro to EMEC, our core business is providing test facilities for ocean energy, but our vision is much broader than that. So we see ourselves as an innovation catalyst, and we have a role in pioneering the transition to a clean energy future. Supplementing that, our mission is to reduce the time, cost and risk of bringing new low carbon technologies to market and into the future energy system. We are based in the Orkney Islands in the north of Scotland. That's where I'm talking to you from today. Our facilities are spread all around the islands. We've got 4 ocean energy demonstration sites, 2 for wave and 2 for tidal in different locations. I'll talk about the wider facilities that we have later, but for just now, we're going to focus in on the wave and tidal test and demonstration. So this is probably a familiar graphic to you all, and it's kind of sets the backdrop to why EMEC was created. So we are a not-for-profit and totally independent test laboratory, the only of its kind in the world that's accredited for testing wave and tidal energy technologies. We were established with public sector funding. So that was from local and national governments, regional development agencies and the EU, hence our name, the European Marine Energy Centre, and we're hanging on to that. Our core purpose was always to test and validate technology so that we can build the credibility and the bankability of projects. And what we see as our role is helping to bridge this gap, which people see as the valley of death. It's the really, really difficult transition from after seed funding investment has begun to run low, but you need to transition and scale up towards commercialization and bringing products to market. So we're quite comfortable to say that this is our natural habitat, the valley of death. But what we need to keep in mind is where we're trying to get to is actually making these technologies investable and attractable to private funders. So our test sites, we have two different types of test site. We have grid connected sites, and these have been chosen for their excellent test environment. We've chosen sites with very strong resources so that they are deliberately challenging for survivability. But we've also instrumented these sites so that they have some pre-installed infrastructure to make it as easy as possible to bring machines to site for testing. So we've pre-installed subsea cables, the sites are characterized, consented, and we have a range of instrumentation for data collection whilst devices are being tested. However, we also spotted that there was a need for non-grid connected test sites. So we also have these, which are pre-consented, and they are used for subsystems, components, or anything you need to rehearse in salt water. We have some pre-installed infrastructure, so we've got mooring points there, but we also have a test support buoy, which has a built-in microgrid. So if you want to measure your power, then you can still do that, even though it's not grid connected. So over the past 20 years, we have tested 35 devices from 22 different technology companies coming from 11 different countries. That has built up a huge amount of cumulative learning by doing, which is really, really important into both how we learn our trade in this sector and what the challenges are, but also how we've actually formed the standards that support the sector. I'm going to give you just one example of the iterative testing that's gone on in our site. So if we look at Orbital Marine Power, they did their first sea trials in Orkney back in 2010 with a small scale device which was tested off the back of a boat. Their first EMIC demonstration came in 2011, and that was a 250 kilowatt device. The learning from those trials, and that was a grid connected project, they then fed into the build of the SR2000, which they brought to our site in 2016. It was almost double the size and 8 times the capacity as a 2 megawatt machine. And they are currently testing the Orbital O2 device. This is a commercial scale configuration of the technology and is currently the world's most powerful tidal turbine, and that is deployed and operating on our site today. So all along the way through these iterative stages of testing, you have the opportunity to pick up both challenges and opportunities for learning. And so we've done the same as a test facility. And Giacomo actually summarised some of this already in his presentation in terms of some of the key challenges for the sector. And we are very, very keen to participate in collaborative research. And again, why we're very pleased to be involved with initiatives such as ETIP and also Marinergy to have a look at how we can reduce the time, cost and risk further for the sector. So to come to the topic of today, our accreditations, each of these accreditations are independent verification of performance data. So each of these demands us to have a series of standard operating procedures, emergency response procedures, and integrated management system, all there to ensure that if you're testing with us, you are well prepared for working to standards. Today, we're going to focus on the testing and inspection standard and RETL status, which is the global status for renewable energy test laboratories. This has all been part of a long time evolution, though, because it was back in 2009, just before I started working at EMIC, that we began to develop a suite of what was at the time 12 standards and guidelines on behalf of the industry. So each document within that suite was written by an acknowledged expert and then progressed by a working group with representatives from technology companies, regulatory bodies, academia, utilities, a true cross-section of the industry. And we sent out more than 4,000 copies of those draft standards. 6 of them were subsequently then taken forward by the IEC, the International Electrotechnical Commission, for global adoption, and these became the first international standards for marine renewable energy. So what are these? So when we look at our testing and inspection work, the core to our capability does lie in power performance assessment. So a power performance assessment is, it provides an agreed methodology for how we measure the power output of a wave or a tidal energy converter in a range of sea states. And it also provides an agreed framework for how we report the results of these measurements. So at EMEC, we can carry out an accredited power performance assessment and then give you an internationally recognised report on the performance of the technology that's been tested on our site. However, we can also provide non-accredited performance reports on our scale sites or anywhere else in the world if the circumstances are not fully aligned with the IEC technical specifications. So next, again, building on these core capabilities, we use the same technical specs and the inspection accreditation then to inspect performance at lower TRLs, so TRL 5 to 7, quarter to full scale, during ocean testing. And at this scale, you don't need to be grid connected, but it provides a really useful path to a full performance assessment, which is grid connected in due course. And then the other thing we can do is provide inspection at tank test facilities as well. Again, same power performance assessment standards, but in the tank, we can also use the standards for mooring systems and also early stage pre-prototype scale devices as well. And lastly, we are also designated as a RETL, which is a Renewable Energy Testing Laboratory. That is the highest international designation for marine energy test labs, and it enables power performance assessment of tidal energy converters, and only tidal at the moment. That's the only accreditation that we hold with RETL, but we do hope to expand that in due course. But having that RETL status, then we can do a power performance assessment anywhere in the world in compliance with the IEC standards. After we got the RETL status in 2020, we did the world's first international power performance assessment for Verdant Power, and that was for their project that was deployed in the New York's East River. So, in summary, to reflect back, some of the benefits of undertaking testing and inspection. And I would work backwards, I think. So why would you think about this when you're tank testing? Or why would you think about doing this if you're putting something in the sea and you're not quite ready to do a full power performance report? Well, all along the way, the better data that you can gather to the more consistent standards, it is enhancing your credibility. By using standardized methodology, it gives you much better reference points. It means you can make better decisions in your technology readiness and your progress towards commercialization. It enables us to identify early issues. So if we come to a tank test scenario, then we might see something that we could see as a difficulty when you scale up into a real sea environment. So it's best to learn that as soon as possible in your design thinking. It also can give you a market advantage. If you have an independently accredited report, then that does set you apart from others. And it also reduces risks, again, by trying to find out problems as soon as possible. All in all, it contributes to just greater confidence in your technology. We're very keen to collaborate with other countries and other test sites around the world. It's really all about building a global market for technologies to sell into in the future. We need this to become a global industry, and what we really want to avoid is this kind of nonsense you find in hotel rooms around the world. So we've led an initiative called the International Waters Network to bring together test and demonstration sites globally so that we can every year get together and share our learning. So going back to the start, this is the scenario that we're trying to navigate. I hope I've explained to you why I think it's really important that you factor testing and inspection and independent standards into your thinking along this path. But if you're not sure what direction to take or when or how best to do that, then please do get in touch with us and we can always help advise. So what next? Well, we are looking at continuing to expand our offering. If you haven't been convinced enough by what you've heard from ETIP and Energy and onshore testing and offshore testing today, then the IEA in December published a report about the need for more clean energy demonstration projects. Many of the technologies that we need to hit our 2050 net zero targets are still emerging. And so there's some important work we need to do to make sure we facilitate the demonstration of these. On our sites, the priority for us, first of all, is to expand our grid-connected sites. So both wave and tidal sites, we want to scale up so they can be array test facilities. Within the next 5 years, on the tidal site in particular, we have almost 25 megawatts of array projects due to arrive. So we need more investment into scaling up the on and offshore infrastructure for that site. We've also gone through a really interesting journey with our demonstration facilities in that we were grid constrained here in Orkney for a long time. And rather than having to curtail renewable generation, we looked to green hydrogen as a way of utilising excess power that was produced. And so we have at our tidal test site now, as well as the tidal turbines generating through the subsea cables into the substation, then we also have an electrolyser so that we can produce green hydrogen and store it. And then we also have a vanadium flow battery shed there. So we've got a really, really interesting energy ecosystem there. And part of the thinking here is how can we look at alternative offtakes for tidal energy in particular? And one of the most exciting prospects we found is actually using green hydrogen to manufacture synthetic fuels. So we did a pilot project where we used our green hydrogen with a company called Zero Petroleum to make some synthetic aviation fuel. And that was a Guinness Book of World Records entry as the first synthetically fueled flight by the RAF. We would like to scale that up as well to provide different offtake solutions for renewables. And lastly, we're also very keen to do more in the floating wind space as well. And we've identified a site which would be more challenging than anything existing at the moment to give floating technologies real survivability and due diligence trials as well. So trying to use all our learning from 20 years of wave and tidal testing to apply to other new emerging sectors as well. And that brings me to round up. Thank you very much. And Lotta, I will throw back to you for the last 5 minutes.
Thank you so much, Eileen. I think that was the best illustration of the valley of death that I've seen with the bridge between the two sides. So thank you very much. Really interesting. I would now ask for the last 5 minutes for all the panelists to come here, put their cameras on, and Eileen, if you can stop sharing so we can all see each other. Great, thank you. So I would like to have a really, I suppose, quite a short discussion, but still a few ideas from all of you on the future of ocean energy testing procedures and facilities. So if we imagine that we are now, going towards more deployment of pilot, pre-commercial, even commercial farms, how will that impact what you're doing, but also maybe looking at the broader picture, the kind of whole testing landscape in general. For example, Eileen, you mentioned that you will want to scale up the wave and tidal testing side. Can you be a bit more concrete on what that will mean? How much capacity will you be able to test that?
Yeah, so we had designed our facilities to test single prototype technologies. And so the idea was we've got 14 cables across our wave and tidal test sites, and we could independently test single machines on the end of each of the cables. It's great now that the industry is actually, particularly in the tidal sector, moving beyond that now. So we're looking at hosting our first array projects on the site, which brings a different flavour to what we do and a whole lot of different learning. In terms of capacity, we are still constrained in terms of where we are on the national grid, which is why we find all the alternative offtake potential really interesting as well. So in the first phase, we're going to be expanding up to about 30 megawatts. And then beyond that, we'll see. But there is a lot of exciting array projects, not just on the EMIC sites, but potentially further around the north of Scotland as well, with some support from UK government as well.
Thank you. And Giacomo, even if we're going offshore, it likely doesn't mean that we will stop doing dry testing, because we need new, more powerful devices and components, optimized components, etc. So how do you see that kind of evolving on the onshore testing side?
Yeah, so as you mentioned, Lotta, it's very important to de-risk the system prior deployment, but it doesn't mean that you need to stop rig testing while you are deploying, because as I said before, reliability is very critical for these systems. So still, we have to prove that this system work well at full scale, but we have also to prove that they work well for a long amount of time. So we have to de-risk each single subsystem, and this takes time. Even if you are upgrading your system, you need to prove that that upgrade is suitable in the long time range. You need to know how much time you need for operating your system and maintaining, what is gonna live longer and what is gonna fail sooner, and you have to know that. So rig testing can help a lot on that. And therefore, we have to support the developers in being capable of addressing all those tests in order that they know very well what they are building, and they know very well how this will work through the years.
Thank you, Giacomo. And Fiona, you were already kind of talking about the future, because the your project is going to set up this system of testing facilities collaborating together. So you can add on anything if you have something you want to say on that. But also, I was wondering, just one question from my side. Once you have this all set up and you can offer, maybe facilitated access, can then anyone come to you and get access to a testing facility regardless of their nationality of the company? It doesn't have to necessarily be local testing.
Yeah, I mean, it will depend on the funded program of access that we will be providing. So a lot of the EU-funded access programs are transnational access, which will mean that they would advocate for people using test facilities in other countries. But we might also have a mixture. I would anticipate potentially national funded access programs, which would be limited in terms of national users, but also transnational access programs. And we also would like to see an expansion in terms of bringing international facilities into our remit in the future. But what we're really focusing on now is the next 5 to 10 years, what the needs are going to be in terms of developing, adding the facilities that are going to be needed by the industry over the next 5 to 10 years. Particularly looking at advising policymakers on where the investment is needed. We need redundancy across Europe, but not too much redundancy. And I think as hopefully the ocean energy sector matures, we're going to need more demonstration sites building up to commercial full-scale test sites as well. So. And also looking at other sectors, including floating solar, is actually an additional category that we recently added.
Thank you. We are running out of time, but if anyone has any final comments, feel free to unmute. If not, I would like to thank everyone. I think as a conclusion, I can say that collaboration and learning from each other, not only between test sites or testing facilities, but also between the developers and testing facilities, is an important point. And doing that onshore testing before then going offshore and creating international standards are some of key areas to focus on to really accelerate the development towards commercialization. So with that, thank you everyone for participating. Thanks for our speakers, and we'll see you in the next webinar. Have a nice afternoon. Bye.
Thank you. Bye.
Thank you, Lotta.
Bye.
Bye, everyone.
Bye.